As I was just mentioning to the rest of the class, this section has a lot of overlap from 5.5. So the first portion of it is like a repeat, so we're not going to do that part. But there are a few examples of applications that you want to be able to do that don't have anything to do with the last section. And we're going to do those three right now. So in this case, you could read the problem in your book, but basically they give us this triangle and they want us to find theta. So we can still use SOHCAHTOA. So which function should we use if we have the opposite and the hypotenuse? Sine, right? So then we're going to get sine theta equals opposite over hypotenuse, which is the same thing as sine theta equal to 1/5. And then how do I find theta?
Inverse.
Inverse, so theta will equal sine inverse of 1/5. And since 1/5 is between -1 and 1, then we're totally okay with that. And I did put up here that you want to make sure that you are in degree mode. So we'll go sine inverse, and I don't have my calculator. Do you guys have your calculator? Here's one. Let's hope it has a battery. Apparently it's my fault for batteries today. So here we go. Yeah, if you weren't here, then you don't know what I'm talking about right now, but it's okay.
Huh?
I'm talking to the camera.
Huh.
They don't know what's going on right now. They're saying like, what is she talking about batteries for? 11.5354 actually, 537 degrees. So it's important that in this case, in the last section it was all about radian mode, so in this section you're going to want to be in degree mode. So that is the answer, so it's not really complicated. But now we're going to get to something a little bit more complicated, primarily because of the directions. So this guy will say find, and the key word is all. It doesn't say find one, it says find all. Find all angles theta between 0 and 180. Again, indicating that we want to be in degree mode. Satisfying the equation. Satisfying the given equation. And I'm going to do two examples of this little guy, one with sine and one with cosine. Okay, so it seems pretty innocent. Here's A, sine theta equals 0.4. And then B will be cosine theta equals 0.4. Okay? So it might actually help for me to kind of draw this out. So I'm going to do that for you now. You get out of my way.
You said equal to this. Everything else is 0.
I'm going to draw both of these guys. Because for the record, you're probably thinking to yourself, it's probably pretty easy to just find the inverse of each side, like we did the last one and be done with it. But it says all, so that's kind of where you have an issue. So first of all, I'm going to do a unit circle of sorts. No, Joshua, it's not perfect, but we don't really care. Okay? Sine theta equals 0.4 means?
That's between 0 degrees and what?
180.
180.
So sine theta is equal to 0.4, which basically means that the y-coordinate is 0.4. So this is supposed to be 1. This is 0.5, so maybe 0.4 is right about here. And this is 0 to 180. Correct? So we're still going to find that basically what they're asking me for. Go over here, Dickie. Ah! Stop being dumb. Okay, forget you. We're going to go with this guy. He's nice. So I'm going to put a dot right here. And I'm going to put a dot right here. Because between 0 to 180, both of these values are the same. They have the same y-coordinate. So that you can see why they're saying to find all of them. Because in this case, there's going to be 2. I'm not sure what it is. Okay? So this guy and that guy. I really don't like that you're not. Okay. All right. So I'm going to do this and do, okay, theta equals sine inverse. Why aren't you working?
Sunday.
Okay, you're driving me nuts.
I'm all
What does that equal? Even though it looks kind of weird up there, I'm going to change that right now, but what does it equal? Can you do that calculator for me, please? Sorry folks at home, or Walla, wherever you are. This pen is having some issues today. We are reconnected here.
This is nice too. 4.12. It's 0.412.
I know. And then we
Okay, what did you get?
0.412.
No, wrong mode. You gotta be in degree mode. So what was it? Theta is approximately 23.6, I guess. Okay? All right? So that's gonna, this angle measure, you can just tell from the graph, is this right here. But we also have this guy defined. Does that make sense? Because you have two solutions there. So when it says to find all of them, you have to find all of them. So now we're just gonna go 180 minus the 23.6, and that'll give us this angle. Because these are both 23.6, correct? So what's this guy gonna equal? What's 180 minus 23.6?
156.4.
Are we okay with that? Yes? So do you understand how you have to find two solutions in this case? Yes?
How
You're looking at me
much?
funny.
No, why did you?
Okay, so we know that the y coordinate is 0.4.
Okay.
So on the y-axis, this is roughly 0.4. It's not quite half, but it's 0.4. There are two angle measures that have that same y value. And once it's to find all of them, we have to find all of them. So in this case, there was two.
But how do you know?
So I did the inverse, and I got 23.6.
Uh-huh.
So that, basically this little angle.
Oh, God.
And then 180 minus that will give me this angle.
Oh, okay.
So, okay, but it's important to know that because now we're going to do cosine, same idea, only now cosine is the x coordinate, not the y coordinate. So cosine 0.4 is roughly right here maybe. This is like half, so maybe it's right here. There's a point there, and there's a point there. So these both are the same cosine value. However, only one of those values is actually within 0 to 180. Right? 0 to 180 is right here. So this guy is not between 0 to 180, so you don't need this one. So for this example, you're only going to have one answer. So I want you guys to know how to tell when it needs two and when it needs one. In this case, it only needs one. So theta will equal cosine inverse of 0.4, which is what? I did this yesterday, and it looks like it was 66.4. But there is no second solution because the second solution is not in the same, it's not in the 0 to 180 window. Now if they had said 0 to 360, we could have also done this guy. Alrighty, so are we okay with that? Okay, so then the next example is going to be non-existent. Hello. Thank you. Weird thing. Okay. It's composing trig functions and their inverses. So what if I gave you this? Find cosine of sine inverse of 3/5. Yeah, that's weird. Okay, suggestions? Hans. Stop trying to write a note card. It's too late for that. Pay attention.
Sorry.
And technically, you were like not here yesterday, so how did you go to the game?
Huh?
Isn't there like a half-day rule?
I'm sick.
There's still a half-day rule.
I wrote an excuse. There are some rules that can be broken
Yeah,
for
really?
the
For Hans?
for the goodness
I mean,
of
it was-
like it's just like
It was for a good cause.
Yeah, okay, whatever. Anyway, back to this.
don't hate.
Any ideas? We did something similar to this yesterday, but the number in here was something that was already in circle, so that we could find easily. Okay, but not so much. Okay, so that's what we're going to do. We're going to say that theta equals sine inverse of 3/5. The reason why I'm going to say that is because I want to find cosine of theta. So all of this is just going to equal theta. We're just going to use a variable and just call it theta. You don't have to call it theta, you can call it W, call it whatever you want. but cosine of an angle. So I'm gonna basically make all of this equal my substitution, if you will, which in this case I'm gonna use the letter theta. If I take the sine of both sides, the inverse will cancel on this side, correct? So then I will get sine theta equals 3/5. Right? If I do sine theta here and sine of the inverse, they will cancel. Correct? So we learned yesterday that they're inverse of each other, they're going to cancel out. So then I just have sine theta equals 3/5. Now I can create a triangle with theta in it and 3/5. So that's going to be opposite over hypotenuse. A little bit of Pythagorean theorem will get you a 4. I'm not going to do that right now, but you guys know how to do Pythagorean theorem. That'll get you a 4. So that basically sets up my triangle, and now I want the cosine of theta, because all of this was theta, remember? So I want cosine theta. So now I'm going to get cosine theta is actually adjacent over hypotenuse. See? So you're done with that. Easy peasy Japanesey. And in a similar fashion, we can do ones that don't have numbers but have like variables. So if you're okay with this one, I will move on to the last example. Jess? So what if I'm doing sine of cosine inverse of x? So see, it doesn't say 3/5 anymore. It says just x. And then what if I want also tangent of cosine inverse of x? Don't get scared. It's still done much the same way. We're going to say that theta is equal to cosine inverse of x, which would then mean that cosine theta is equal to x. We like to have a fraction because with SOHCAHTOA you want a fraction, right? Top and bottom, so we can just do that. And then we can still set up a triangle with those properties. Cosine is adjacent, so that would be adjacent over hypotenuse. Yes? And we could use Pythagorean theorem to figure out that if we want to call this y, then we could say that, x squared plus y squared equals 1. So then y squared would equal 1 minus x squared. And then we'd square root that. And it turns out that this side that we just called y is actually the square root of 1 minus x squared. Correct? So if I want the sine of theta, sine theta is going to be opposite, which is the square root of 1 minus x squared, over hypotenuse, which is 1. So it's just the square root of 1 minus x squared. That would be your answer for the first part. Now you'll notice that for the tangent one, this is the same inside as this guy over here. So the same theta applies, so the same diagram applies. And so now I just want to find tangent of the same angle. So tangent is opposite over adjacent. So the opposite side is square root of 1 minus x squared divided by the adjacent side, which is x, and this would be your final answer. Square root of 1 minus x squared over x. So you can do this without having the actual values like 3 or 5 or whatever. You can do it with variables involved as well. Alrighty, and that's basically the only new stuff that you're going to see in this section. So Hans, if you would be so kind as to stop my recording now, I might forgive you for yesterday.
Where's the button?
It's on
That's the one that
the
says
right.
record.
It says all.
This?
There you go.
Just the one.
Yeah.